Welcome to Study Loop.
Okay, so we have a circuit here that has point A and point B, and beyond point B there is yet another resistor that is 200 kilo ohms, and between A and B there is a resistor of 100 kilo ohms, right? And the end of 200 kilo ohm is earth end. Now the question says that point A is maintained at a constant potential of 400 volts. Right now, for the part A of the problem, there is a voltmeter that is connected in parallel, obviously parallel, right, between point B and ground. So when the voltmeter is connected between point B and ground, this is point B, suppose, then if the voltmeter is connected, then there are two resistances. One is 1100 kilo ohm, and the other is 200 kilo ohm combined with the resistance of voltmeter, right? So the voltmeter is in parallel, so this resistance is always 100 kilo ohm, whereas this resistor here, this is 200 kilo ohm parallel the resistance of voltmeter, that is 5 into 10 to the power 4, right? Resistance of voltmeter is equal to 5 into 10 to the power 4 volts. So let me write this in kilovolts, kilo ohms. It is in ohm. Let me write this in kilo ohms, so that is 50 kilo ohm, right? Yeah. So the equivalent resistance is 20 parallel 50, which is equal to 40 kilo ohms. Okay. So now we have reduced the problem into two resistance. One is 100 kilo ohm and the other is 40 kilo ohm. Now we have a potential of 400. Now this potential needs to be divided among 100 and 40, right? So the potential divides with proportion to the resistance. That is, the ratio of resistance would be the same as the ratio of voltages. So voltage V that we need to determine, this the voltmeter measures, is equal to 40 upon 100 plus 40 into how much? The total voltage is 400, so into 400. So this gives me the voltmeter reading would be 114.29 volts, right? So we are done with part A of the question. Now let's move on to part B. Okay, if I make it of different color, then that will be easier for you to understand. Now part B says, now the voltmeter has a resistance of 5 into 10 to the power 6. So the resistance would be now, let me write here, for B part the resistance would be 200 parallel, how much? Now it is 5 into 10 to the power 6, so that is 5000 kilo ohms, right? And this should be equal to 192.3 kilo ohms. Now for part B, this means that voltage V would be how much? 192.3 upon 100 plus 192.3 into 400, which gives me the voltmeter reading would be 263.165, right, volts. So we are done with part B of the problem. Now for part C, let me use red. Okay. For part C, what is the voltmeter with infinite resistance? So if the resistance of voltmeter is infinite, no current flows through B, right? So the equivalent resistance of the combination of voltmeter and 200 would be just 200, right? So now B would be 200 upon 100 plus 200 into 400, right? This should be equal to 266.67 volts, right? So you you should you should have observed that higher the resistance of voltmeter, nearer is exact is the value. So that's why voltmeter have higher resistance, right? So this is the end of the solution. Thank you for watching.